Hi friends, welcome back. This is the problem 24 and the last problem of this set 2074 RE109CC, and this problem is what we generally used to call and is still popularly known as the out theorem, and this used to be the nightmare of the students. So the average students would not dare to do this question, but that's not true. It is not the nightmare. So if you get the question, or if draw the, or if you have figured out the structure of the question, so for this case no figure is given, you have to draw the figure yourself. So what that does is, if you draw the figure correctly and you understand the situation, so it is just like the in theorem that we did in question 16, where we proved the area of two parallelograms equal, right? And if we look at the solution, this will pretty be very simple. All right, so let's not be afraid of these type of problems. We should be able to do everything that we are asked to do. All right, let's go into this problem then. Let's start by drawing the figure. All right, so solution. And since we have cyclic quadrilateral, we obviously have a circle, right? And we have w x y z as the cyclic quadrilateral. So let's assume this point w and x and y and z or g as cyclic quadrilateral, right? If the bisectors of angle x w z, so x w z means this angle, and angle bisector means this angle is divided into two equal parts, half half. All right, and angle xyz, so angle xyz means this angle. So the angle bisector of these two, so angle bisector of these two may not be the same. All right, so we can't say that the same line will divide these two angles into half. So if these two angles are bisected, right, so the respectively means xyz is bisected by the at point p, and sorry, xwz is bisected and the line meets at p, and xyz q, right? So xwg, so we'll say p will bisect this, right? So let's assume that, so this point is p, that means this line pw is bisecting this angle, right? And for y, let's assume q will bisect this. All right, mm, yeah, so and meet the circle at this, then prove that pq is the diameter of the circle. All right, now let's say that this is the point q. All right, so we need to show that this pq is the diameter of the circle. So to prove the diameter, we already have used one theorem, that is the angle subtended by the diameter at the circumference is equal to 90 degree. So if this pq is diameter, then, so if I draw this construction, if I join this w and q, so this angle pwq should be equal to 90 degree. So we can write given information here, right? And we can say to prove pq is diameter, or we can also prove angle pwq is equal to 90 degrees. So if angle pwq is equal to 90 degree, then the pq will be the diameter, right? Yes. So what else to do? And we know that these angles, so say this angle is, right, so if this angle is, let us consider theta and theta, because these two angles are equal, and since this whole angle was bisected by this line, let's say this angle is alpha, this angle is alpha. So from the relation of the cyclic quadrilateral, actually these two angles when added should be equal to 180 degree. So from relation of cyclic quadrilateral, because these are the opposite angles, right? We proved, we find out the relation, experimentally verified that these things. So angle P, or not angle P, so angle XWG plus angle XYG is equal to 180 degree. So I have considered XWG as 2 alpha and XYG as 2 theta. So this is equal to 180 degree. So this gives alpha plus theta equals to 90 degree, right? So this is one of our relation. And the other thing is, so if this angle, let's say, or we can directly write angle QYG, right? So angle QYG means this angle, theta angle, right? Angle QYG is equal to angle QWG or Z, right? So this angle here, because they are standing on same arc QZ, right? So both of these are standing on same arc QZ. So we have done similar kind of problem in short questions, right? So what this does is it will give the value of angle QWZ, right? So angle QWZ will be equal to theta, right? Because angle QYZ is equal to theta, or we can simply leave it in terms of QYZ, right? Now let's find out angle PWQ. So angle PWQ is equal to angle PWZ plus angle QWZ, right? So angle PWZ is alpha because the whole angle is 2 alpha, right? And it was bisected. So angle PWZ is alpha plus angle QWZ is theta, right? We just find out here. This is equal to 90 degree from a relation first, right? From equation 1. So we proved that angle PWQ is equal to 90 degree. This is only possible when PQ is diameter. Otherwise, this is not possible. So we proved, and we don't have to write statement reasons. If you want to write, you can write, but you can simply write the reasons at the side, on the right hand side there. So we can say that at first we can simply write first step, second step here, right? Third step, calculation of this, and yeah, and the marks distribution will be, you will get 1 marks here drawing the figure, correct figure, and 1 marks from these points, right? You find out these relation between the two angles, or you used the relation of cyclic quadrilateral, and 1 marks here because you used another theorem that is standing on the same arc, right? And this one is the fourth, so you combined all these, right? And finally 1 marks here, where you proved whatever it was asked. So this is how the marks will be distributed, and for each step you will get each type of marks. So even if you do one step wrong and the other steps right, you will still get the marks for the steps that you have done right. Okay, This is how the marking system works for every kind of problems, not just for 5 marks, 6 marks, 4 marks, for everything. Okay, clear? All right, very good. And this is the last problem. So I hope to see you in another videos, and hopefully you will do your best for your exams and get 100 out of 100. So all the best for your exam, and hope to see you soon in another videos. Good luck.